In this video we're going to look at compound angles. Well, what do we mean by compound angles? Well, we're interested in the sine function here, so I've drawn the sine function out there. Now we're interested in a compound angle, that is an angle which is made up of two other angles. So in this instance we're looking at the sine of some angle x plus another angle a. So if we click on this here, we'll give the option of adjusting the value of a. Now we know from what we've done with manipulating functions that if we would had the value of f of x plus a, well, plus a would be equivalent to taking the function and shifting it to the left, and minus a would shift the function to the right. So all this is going to do is shift the sine function left or right. So let's go ahead and we'll move that just now. So there we can see that that function is now getting shifted. So as a is positive, the function is going to get shifted to the left, and when a is negative, the function will get shifted to the right. But we're interested in this new function sine of x plus a. Now sine of x plus a is not the same as saying sine of x plus the sine of a. In fact, we can have a look at that just now. We know that this here is a function sine of x plus a. So what would be sine of x plus the sine of a? Well, that would be this function here. This function here is not the same as that function. So whenever we work out this sine of x plus a, this is not the answer. What we are interested in is what new function gets generated when we add or subtract off some value at some other angle. And we're interested in doing that for both the sine function and the cosine function. So here's another simple way of looking at the compound angle equation. So if we start off at a value of 0 here, if we shift this round about and we'll pick up a random point here, so this point here, now we've got three different lines here. We've got the red one, the black one and the green one. Now the red one is going to make an angle, we just call it angle 1, so that's angle 1 here. The black one makes an angle which is angle 2, and the green one makes an angle which is angle 3. But we've set it up here so that this angle 3 is equal to angle 2 plus angle 1. So when we add in the red angle and the black angle, we get the green angle. So then what we do is we take the sine of angle 1, the sine of angle 2 and the sine of angle 3, and this gives us the values here that we see. So in effect, if the length here is 1, so it's just the radius of the circle is 1, then the sine of this angle here is simply going to be this height, and the sine of this angle here is simply going to be this height, and the sine of this angle will be this height here. So if we were to then look at creating the sine of angle 1 plus the sine of angle 2, then that's not going to be the same as the sine of angle 3, because what we would be saying then is that this height here, which is the sine of angle 3, would be equal to this height plus that height, and they're not the same. And you can see that quite clearly if you move it further round. I'll move it, say, round to this point here. Then if we say sine of angle 1 plus the sine of angle 2 equals the sine of angle 3, then we would be saying that this height here plus this height here equals this height here, which is patently absurd because the sum of these two heights is going to be greater than the sum of this height, and that's what it shows us here. The sine of angle 1 plus sine of angle 2 is a value of 1.629, but the sine of angle 3, which is the big angle round here, is 0.863. So this shows us quite clearly why it is that whenever we work out the sine of alpha plus beta, it's not the same as the sine of alpha plus the sine of beta. So let's have a look at these in formulas, and we're not going to derive the formulas, but we'll just state the formulas and we'll see how we're able to use them to solve problems. So these are the compound angle formulas, which are just stated. So we have the sine alpha plus or minus beta is equal to sine alpha cos beta plus minus cos alpha sine beta. So there's actually two equations wrapped up into this. So if it was alpha plus beta, then the sine is a plus, and if it was alpha minus beta, the sine there is a minus. Now the other one is cos alpha plus or minus beta. That is equal to cos alpha cos beta minus plus sine alpha sine beta. So the thing you have to be careful with this one is that there's a change in the sign. The plus sign here will become a minus sign here, and the minus sign here will become a plus sign here. So those are the four equations that, again, we've just stated, we haven't proven, and we're going to go and have a wee look and see how we actually use these equations to solve some problems.